the students in my YouTube channel Physics by TC Chauhan sir. Today we are again with you by 12th board special. We shall discuss few topics based upon magnets. We shall discuss today about the Earth's magnetism and magnetic materials. Students, you should share, you should like and you should subscribe my channel. These are very useful in several competitive examinations. Today we shall discuss about those. Now, let us start from Earth's magnetism. Listen, Earth itself behaves like a big magnet. It has definite magnetic poles. Earth can act as a magnet as a huge part having the magnetic north and magnetic south, which are exactly opposite to that of geographic poles. Students, here we consider this is supposed to be Earth. It has geographic pole, geographic north and geographic south. This is geographic south. It is a magnetic pole. Toward north geographic there is south magnetic, and toward south geographic there is north magnetic. This is north magnetic. This line which is joining the magnetic poles is known as magnetic axis, and this is geographical axis. This angle, that is angle between geographical axis and magnetic axis, varies from 11 degree to 17 degree. Now, what about magnetic axis? Magnetic axis is line joining Earth's magnetic pole. What about magnetic equator? It is just perpendicular to magnetic axis. It has particular magnetic field lines which are starting from north magnetic and ending at south magnetic. These are escape for large distances and up to 32,000 kilometers. These are available. Earth's average magnetic field is approximately 10 to the power minus 4 Tesla or 1 Gauss. It is very small. It is not too much high. How we can say that Earth is behaving like a big magnet? There are few evidences. Whenever someone is going to suspend a bar magnet freely, he will find that the north and south pole remain always toward geographical poles. It means north pole will, magnetic north will point geographical north. That means there is south magnetic pole. So this is about the tendency of the existence of magnetism. The other can be if you are digging at a certain place and burying a magnetic material. After a long time, it will become a magnet. That means it is inducing the magnet, and something which can induce if and only if it itself is a magnet. The third thing is that whenever you are drawing magnetic field lines, you will have particular points, and these points are known as neutral points, and their existence will indicate that Earth itself behaves like a big magnet. There are few conditions of Earth's magnetization. The several scientists which have given several concepts. What are those concepts? Let us discuss. If we discuss about the existence of Earth's magnet, a scientist, William Gilbert, has told that at the center of Earth there is a big magnet or huge magnet. What is the condition? Let us discuss about that condition. The condition is it has a particular magnetic moment and it provides magnetism to Earth. It is not true, students, because at center of Earth the temperature is too high. A magnet cannot survive at all. The survival of magnet is not possible. So this theory failed. Now another theory is at equator of Earth the hot air rises up and move toward the poles. During this, these will get ionized and behave like current carrying loops, and provide magnetism to Earth. It may possible, yet there is no such proof. The third thing is, around Earth there are several atmospheric layers: troposphere, stratosphere, mesosphere, ozone layer, and ionosphere. The ionosphere is basically ionizing gases. With the rotation of Earth, this ionosphere also rotates, and when it rotates, it will behave like a current carrying loop, and it can provide magnetism to Earth, because at center of current carrying loop there is magnetic moment. Now another thing, it is said that at the center of Earth there is a semi-liquid core. With volcanic eruption, we can observe that this semi-liquid core is present in the form of lava. At the center, with the rotation of Earth, this semi-liquid metal core will rotate and behave like self-induced generator and provide magnetism to Earth. Let us discuss about elements of Earth's magnetism. There are basically three elements. One is angle of declination. Angle of declination. This angle of declination is angle between geographical meridian and magnetic meridian. This angle is supposed to be phi. So what is angle of declination? Angle between geographical meridian and angle between magnetic meridian. It is different at different places. Second is angle of dip. Angle of dip is whenever a magnetic compass or bar magnet is freely suspended, then it will always remain at certain angle theta with horizon. This angle of inclination is known as angle of dip. Whenever angle of dip is measured at the poles of Earth, it will be 90 degree, and whenever it is measured at equator, it will be theta is equal to 0 degree. Remember, it can be asked that whenever a bar magnet is kept on poles of Earth, what it become? It become vertical, because angle of dip is 90 degree. Now let us discuss about the third one. Third is horizontal component of Earth's magnetic field, that is BH. We know that Earth's magnetic field B has two components. One is horizontal and other is vertical. The vertical and horizontal components are mutually perpendicular. Then the resultant will be B is equal to under root BH square plus BV square. This horizontal component is more important. So this is said to be the element of terrestrial magnetism, elements of Earth's magnetism. Students, what it be in terms of angle of dip? That will be cos theta is equal to BH upon B, and sin theta is equal to BV upon B. These two equations will give tangent law, and that tangent law is tan theta is equal to BV upon BH. It is very important as far as we concern about numericals. Now let us discuss about the different magnetic materials. Basically there are three kinds of magnetic materials. These are diamagnetic, paramagnetic, and ferromagnetic. First of all, we discuss about diamagnetic materials. Diamagnetic. Those materials which when kept in external magnetic field experience weak repulsion. If the material kept in external magnetic field, it is going to trying to move away from the magnetic material. It means it is feeling repulsion. These are the diamagnetic materials. These can be bismuth, these can be mercury, these can be gold or silver. Now, what is cause of diamagnetism? The basic reason of diamagnetism is paired electron existing in an atom. In these materials, every atom has paired electron, and each pair, the orbital motion and spin motion is exactly opposite. Because of that, the net magnetic moment in the absence of magnetic field will be 0. This is M1, this is M1, then net M will be 0. But if it is kept in external magnetic field, then what happens? Then there will be a force called Lorentz force which is acting, and because of Lorentz force, this magnetic moment will exceed in particular direction and will decrease in opposite direction. Here there will be negative sign, minus delta M. So net magnetic moment will be there in terms of 2 delta M, and it is opposite to B, that is external magnetic field, and being opposite, this material will experience weak repulsion. This is about diamagnet and diamagnetism. Now, what about paramagnetic substance? Those substances which when kept in external magnetic field. Second is paramagnetic substance. Those magnetic material which when kept in external magnetic field has tendency to move towards the magnetic field with a weak attraction force. Paramagnetic material can be liquid oxygen, can be copper chloride. These materials have a particular cause, and that is the cause of paramagnetism, and this reason is unpaired electrons existing in atoms. And because of unpaired electrons, each atom will behave like atomic magnet, and in the absence of external magnetic field, these atomic magnets are randomly oriented, so net magnetic moment will be 0. This is B is equal to 0, then M is equal to 0. Random arrangement. If B not equal to 0, then student, listen, then these will get arranged along the direction of B and give magnetic moment along the direction of B, and doing so, these material have tendency to remain in that direction only. So this is about paramagnetic materials. Now we discuss about the third type, and that is ferromagnetic materials. Ferromagnetic materials. These materials are the metals or materials which have tendency for strong attraction towards magnetic field. When these are kept in variable magnetic field, these have tendency to move from low magnetic field to high magnetic field. That means these are going to attract with a larger force, strong force. This is due to the attraction of domain arrangement and domain structure. The example of ferromagnetic material is iron, nickel, cobalt, chromium. Now, what is the cause of ferromagnetism? Why ferromagnetism exists in the metals? The basic reason or basic cause of ferromagnetism is unpaired electrons and partially filled inner orbits and domain arrangement. Remember, unpaired electrons, partially filled inner orbits and domain arrangements. Now, in which kind these existence are exposed? In such materials, every unpaired electrons have tendency to make the neighboring electrons to spin along with and creating the domains which are in a particular direction. But in the absence of external magnetic field, these domains are randomly oriented and net magnetic moment will be 0 if B is equal to 0. But in the presence of external magnetic field, these domains will get arranged along the direction of the magnetic field, and magnetic moment will be along the direction, and the net magnetic moment will not be 0 and net magnetic moment will be along B. So this material has tendency to be attracted towards magnetic field by strong force. This is about the types of magnetic materials. On this basis, there are two laws. One is Curie law. According to Curie law, the magnetic susceptibility of paramagnetic substance is inversely proportional to absolute temperature. Chi proportional 1 upon T. Chi is equal to C upon T, where C is Curie's constant. But this is applicable for paramagnetic substances only. What about ferromagnetic substance? For ferromagnetic substance, magnetic susceptibility is given by Curie-Weiss law, and this law is chi proportional 1 upon T minus Tc, that is chi is equal to C upon T minus Tc. Tc is Curie's temperature, the temperature below which material remain ferromagnetic, above which material remain paramagnetic. This is all about the types of magnetic materials. Hope that these will be useful for upcoming examinations, and if you like this, if you are having any problem, you should go to the comment section. Please do share, do like, and do subscribe our Physics by TC Chauhan sir YouTube channel. Thank you.